All right, I'll walk you through this problem here. The count in bacteria culture was 300 after 20 minutes and 1700 after 35 minutes. Assuming the count grows exponentially, what was the initial size of the culture? Okay, so this is not the initial. You put 300. This is not the initial because it's 20 minutes. Initial would be times 0. So what we're going to look at is using this information, though, to find what the rate is. So if we go, and I'm not sure, I don't watch the video that Cheryl gives. Not sure what variables she uses. So I'm going to use the amount at time t is equal to the initial amount. So I call that a sub 0 times e raised to the r times t, where r is the rate of increase and t is time. If I have this information, and t is time, and time is going to always be in hours. So what I'm going to do is use this information in this here to provide me some information. So the amount at time of, so we started with, in this concept, 300 as the initial amount. Well, it's not the time 0, but it's the initial amount that they provide us in this problem, because we got to find r. So they give us 2 points of and I mean, if we were to look on an xy axis, they give us like 300 at 20 minutes. So let's say that's 20 minutes, and let's say that's 300. And then they say at 35 minutes, you're up at 1700. So they give us these 2 points. We can use those 2 points to try to figure out what the rate of increase is. So that's what I'm going to do. So 300, a sub 0 right now, e, okay, r, I don't know, okay. Now, t, what I'm going to do is put t in here as the difference between those 2 times. So 15 minutes out of 60. So I'm going to put this in, it's always in hours. So dividing by 60 is going to get it back down to minutes that some of these problems ask about, parts of these problems ask about. And the amount after that 15 minutes ends up being 1700. So with that information there, we should be able to solve for r. So I'm going to take, divide by 300 to both sides. So it gives me 17/3 is equal to e raised to the r. 15 divided by 60 is just 0.25, so I'm just going to write that way. Now to get that variable out of the exponent, we're going to take the natural log of both sides. And so on this right hand side, what that would actually look like would be the oh, that's big. Would be the ln of e to the 0.25 r. Okay, and when we look at our logarithmic rules, we can take that out front. 0.25 r ln e. Well, ln e is just 1, so you get that 0.25 r. So that's what I'm just going to write here is 0.25 r. So now if I divide ln of 17/3 divided by 0.25, that equals r. Get my calculator out. Natural log 17/3 divided by 0.25 r. So my rate is 6.938. And I'm going to, because I'm going to come back and use this calculator quite a bit, and I want to use that exact value. So I'm going to actually hit STO button on my calculator. I'll find the variable r, or the letter r. Oh. Alpha r. Hit enter. And now every time I hit r on my calculator, it's going to use that 6.938 number. I'm just going to make rounding a little bit nicer as we go through the rest of the problem. All right, so that's not what they're asking for. Okay, they want to know what was the initial size of the culture. So what we're going to do is we're going to go back through this using the same formula. A of t is equal to a sub 0 e to the RT. But now we're going to say, using that first point when they said we had 300 after 15 minutes or so, or I guess it was 20 minutes, I'm going to put 300 here. Okay, a sub 0 is the initial amount. I don't know what that was. E, now my R is the 6.938 number, times T. Well, when did I have 300? I had 300 after 20 minutes. So, again, in hours, so I'll take 20 divided by 60. Now, in order to get what a sub 0 is, that's just a coefficient here, so I'm going to take both sides and divide it by e to 6.938 times 20/60. Do it to both sides, so that's going to give me 300 divided by e to the 6.938 times 20/60 in the denominator, and that will give me a sub 0. So, go to the calculator, 300 divided by e, okay? Now it's raised to 6.938, but remember I made that the r value. So I'm going to put r in there, and now 20 divided by 60, hit enter. In there I get my I get my 29.695 07085248 that they were looking for there, my initial size of the culture. So again, because I'm going to use that value quite a bit, moving throughout the rest of this, and you don't have to do it this way with the variables, but I'm just gonna hit STO and alpha A, and now I've stored A as 29.69. Next part says find the doubling period. Okay, well, the doubling period, and you can start here. What people struggle with sometimes with these is that the word doubling is giving you the amount at time t and the initial amount. It's just kind of hidden in that concept of double. So you can start with any amount that you want. You want to start with 13. Then what would it be when it doubled? When it doubled, it would be 26. If I want to start with 130, when it doubled, it was 260. You can start with any amount that you want. So I'm going to start with 1, and then when it doubles, it becomes 2. And the idea here is that every single time that you do this, because that whatever you chose here as your coefficient, when you try to solve for t, the first thing is to divide both sides by that coefficient there. Well, if it was 13 and this was 26, I would divide by 13 and I would get 2 and 1. So I always just start with 2 and 1 because I know what it's going to get to. All right, so I divide both sides by that coefficient of 1, so it just gives me, obviously, 2e to 6.938t. Now, to get that t out of the exponent, we take the natural log of both sides, so natural log of 2. Take the natural log of the right-hand side, e 6.938t. And when we have this, remember, taking the exponent rules as before, we can take that, put it out front as a coefficient. So I have ln of 2 is equal to 6.938t ln of e. Well, ln of e is just 1, so effectively get rid of it. And now I'm going to have ln of 2 divided by 6.938. That will give me t. Okay, so we'll go ahead and do that. Get my calculator disappeared. All right, so ln of 2 now divided by the 6.938 number, which I have that stored as r. It gives me that. Okay, so now that's kind of weird because that's not what the answer is asking for. Remember, that's hours. Every time I solve for t, it's in hours. So if you look at, and I don't know, it doesn't say to put it in minutes. It doesn't say what kind of unit to use. I don't know if it would accept 0.09999 and be able to determine that it was in hours. But because the problem is giving me information in minutes, I'm going to change it to minutes. So if I multiply that by 60, you're going to see the 5.994 051784 number that we're interested in. Okay, so the next question is find the population after 80 minutes. Okay, so we'll do this after 80 minutes. So a of t is equal to a sub 0 e to the r t. Okay, so we want after 80 minutes. So we're basically, the question is, what is the amount after 80 minutes? Well, the a sub 0, remember a sub 0, what was the initial amount? We found that previously. It was the 29 number. It was this number right there. Okay, so we'll plug that in as a sub 0, 29.695 is how I write it. E to the r, well, r was 6.938, and t needs to be in hours, so it's 80 minutes over 60 minutes. And that should then be able to be typed in directly. I'm going to use, remember I have that 2.969 number stored as a, so I go a, and then second e raised to the 6.938. Remember I have that stored as r, and then we'll take it and multiply it by 80 over 60 and see what that gives us. 309337. 0.037037 repeating. Okay. So the next part is, when will the population reach 12,000? Okay, so we're looking for, when does, again, I'll start with the basic a of t is equal to your initial ERT. When will it reach 12,000? So that's the amount after t. When will it reach 12,000? We started with 29.695. R is 6.938. We're looking for t. Now when I do this, t is going to be in hours. So just going to be careful of that. Take both sides, divide by the 29 number. So I have 12,000 divided by 29.695 is equal to e to the 6.938 t. I'll natural log both sides. To 9.695 equals, now if I take the natural log of that side, what it's going to do is take the exponent out front and leave me ln of e, which is just the 1. So I'll just read it this way, or leave it this way. So now I divide by 6.938. So I go ln 1200 to 9.695 divided by 6.938 is equal to t. So we're going to put that in. Natural log 1200 divided by, now remember this 29.69 number, I have that as A, so I put A in, divided by then that whole thing divided by 6.938, which I had as R. And that's just like I said, that's just allowing me not have to type in those long decimals or round them and have some rounding error. Hit enter, gives me that number. Remember, that's hours. Okay, so I'm gonna multiply that by 60 to get my minutes, and we see the 51.899 that they're looking for there.